Welcome to The Explainer. Today, we're going to tackle a really fundamental question about the internet. How do you talk to a device that has no screen, no keyboard, but somehow runs our entire digital world? We're diving deep into the world of Cisco switch management, starting from that very first physical handshake, all the way to secure remote command. All right, so picture this. You've got this brand new, super powerful network switch. It's got the potential to be the heart of your whole network, but it's just a box. A completely blank slate. There's no display, no mouse, no keyboard. So how in the world do you even start talking to it? How do you tell it what to do? Well, the answer to that puzzle is a special direct connection known as the console port. This is your very first point of contact. It's the initial handshake between you, the administrator, and the machine. Yeah, you can really think of the console port as a backstage pass. It's a direct lifeline to the device's brain. It's an actual physical plug that you connect to with a special cable. And what's cool about it is this direct link completely bypasses the network, giving you raw, unfiltered access right to the command line. And this is why that console port is so absolutely essential. It really plays two major roles. First, there's the whole initial setup phase. You've got a device fresh out of the box, right? There is no network connection yet, so this physical link is literally the only way in to give it its first set of instructions. Then you've got the emergency access side of things. This is your safety net. If the network goes down and you lose all your remote access, you can always just walk up to the device, plug in, and fix whatever's wrong.
But let's be real. Once that switch is up and running on the network, you're not going to hang out in the server room for every little tweak. That's just not practical. It's time to manage it remotely from pretty much anywhere.
So that brings up the next big question, right? The device is humming along in a data center, maybe miles and miles away. How do you get to its command line without being physically plugged into it? We need a virtual way to connect. And the magic behind this is something called virtual terminal lines, or VTY for short. The best way to think about them isn't as physical ports, but more like virtual doorways that the switch opens up over the network. It's like having a bunch of phone lines going into the device, which is also why multiple people can connect and work on it at the exact same time. For years, and I mean years, the standard way to walk through those virtual doors was a protocol called Telnet. It's kind of the old school original way to do this, using the famous TCP port 23 to make the connection. But here's the catch. Telnet, as convenient as it was, had this massive, glaring security hole, a real hidden danger that became a huge problem as networks got more and more serious about security. And the source material really hits the nail on the head here. It says Telnet is not secure because it sends data in clear text. Now, what does that actually mean? It means everything, and I mean everything you type, your username, your commands, and most importantly, your password, it's all just flying across the network in plain, readable language. This postcard analogy is just perfect. Using Telnet really is like writing your most sensitive secrets on a postcard and dropping it in the mail. Anyone who happens to be listening in on the network, anybody, can just read it. No effort required. It's kind of terrifying when you think about it. So obviously, this couldn't last. The industry desperately needed a secure way to do this. We needed all the convenience of remote access, but without that giant security risk. And that is where SSH comes into the picture. SSH stands for Secure Shell, and it was literally built from the ground up to fix Telnet's big mistake. Instead of just sending your data out in the open, it creates this secure, encrypted tunnel between your computer and the network device. And really, this comparison tells the whole story. It's night and day. On one hand, you've got Telnet on port 23, totally insecure, sending everything in clear text. On the other, you have SSH on port 22, wrapped in layers of encryption. In any professional setting today, this isn't even a choice. Telnet is just a massive risk you don't take, period. Okay, so setting up SSH isn't just flipping a switch. There's a logical path to it. First, you've got to give the device an identity, a host name and a domain name, so you know what you're connecting to. Then, and this is the really important part, you generate these special cryptographic keys. Think of them as the secret code for your secure tunnel. After that, you create user accounts to make sure only the right people can log in. And finally, you tell those VTY lines to only listen for SSH connections. You basically slam the door on Telnet for good. All right, let's bring this all home. Why does any of this actually matter? Because choosing the right tool here isn't just some techie detail. It's a fundamental security decision you have to make. So here's your toolkit, all boiled down. You've got the console port. That's your physical lifeline. It's for that initial setup, or for when everything hits the fan and you need to get in. Then you have Telnet, the old insecure way. Just avoid it. And finally, SSH. This is the modern, secure standard for pretty much all remote command line work. It's the only way to go. And that leaves us with one final, really important question to ask yourself. Your network is connected, sure, but is it secure? Because in today's world, an insecure connection isn't a feature, it's a bug. It's a vulnerability waiting to happen. And making that conscious choice to use SSH over Telnet, well, that's one of the first, most critical steps you can take to build a network that's not just connected, but truly strong.